Irodov problem number 1.69. A bar of mass m resting on a smooth horizontal plane starts moving due to the force F equals mg by 3 of constant magnitude. In the process of its rectilinear motion, the angle alpha between the direction of this force and the horizontal varies as alpha equals as, where a is a constant and s is the distance traversed by the bar from its initial position. Find the velocity of the bar as a function of the angle alpha. Okay. So here is a bar, mass is m, there is a force acting on it. This is alpha at any time. F is given as mg by 3 and alpha varies as as, where s is the distance traversed by the mass starting from rest. Okay, so at t equals 0, s was 0. So initially the force was like this and slowly the alpha increases. Okay. What we need to find out is the velocity of the bar as a function of alpha. Cool. So first thing, let's do a free body diagram. So mg acting like this, F acting like this. This is mg by 3 in magnitude, but at an angle alpha. And normal reaction works like this. Okay. Now, one thing we should consider is, let's say, normal reaction plus F sine alpha, component of force in this direction, equals mg if the body does not leave the surface. Now, body will move along the surface as long as n is not equals 0. So let's first investigate if n can be equal to 0. If n is 0, F sine alpha equals mg. So sine alpha equals mg by f, and f is given as mg by 3. So this turns out to be 3. Now, since sine alpha cannot be greater than 1, not possible. So therefore we conclude that the body will never leave the surface. Okay, so that's one thing. All right, okay. Now, what is responsible for the body to move in this direction? Let's say with acceleration w. F cos alpha, which is forces component in the direction, in this horizontal direction, is responsible for the acceleration of the body, mw. Okay, so we can write, now F is mg by 3. Okay, so mg by 3, and cos alpha is as, so let's just write that, is equals to m. Now w we can write as dv dt. Okay, further I'll say we can cancel out the m's, so g by 3 cos as, we can further write dv dt as dv ds times ds dt. Now ds dt is v, so this is v dv ds. Okay, now let's take ds that side, so we get v dv equals g by 3 cos as ds. Okay, now we integrate both sides. So since it starts moving, so limit is 0 to v, and displacement when it started was 0 to s. Okay. So this becomes v square by 2, and this side we can take g by 3 outside. Integral cos as ds will be sine as by a. Okay, and limits are 0 to s. So if I write it this side now, so v square is equals to 2g by 3 sine, or 2g by 3a sine as minus sine 0 is 0. Now v will be equals to root over 2g by 3a sine, now as is nothing but alpha, so we can write alpha. So my velocity as a function, of alpha is this. Okay, so that is my answer.